Papa Bale. Right, so we want come on, I hate that. Just lose your strength grip on it. This will go here. That is a 470 ohms. I'm trying to run SG. We can get the second one to run, but then the first one stops. Then I unhook the SG. So I thought it might have been a resistor. It was doing that. Let's see what it looks like. See, that will run.
Wow, that almost. Interesting.
Alright, now I'm going to cut the power. And I'll be running some pretty cool stuff with this, but I don't have any transistors that'll work with it. So we're going to disconnect the continuance. And that's off the collector. Now, it should work well. I don't know about the resistor though. Oh, dang. What's that? Oh, the coil.
I see.
Core.
That's what was doing it?
No, that wasn't what was doing it.
Oh, okay.
It just happened because it was happening.
Got it.
Alright. Wow. So, I was doing better without this. I was just trying to run two pulse motors at the same time. I'm not scrapping it, I just have to start fresh. See if it's even functioning still. Alright, so I'll put the light and the shot ski over here. Crank it up a little bit. See if we're done with this already. I don't know, I can't. See, these are really close together. So, I don't know about that. Don't know if that's affecting anything. This might be it right here. And then I gotta wait for the transistors that I chose. Because the ones that I was running with are out of stock. It looks like it's going to work just fine. But, yeah, there it goes.
Oh, yeah.
But you notice how the coil's not triggered. It's not squeaking.
Yeah.
It's an internal and it's not squeaking. So that's different. That's new. It's new for me, but it's definitely working when it's not squeaking, and it's freaking stuck when it is squeaking. So I'm good. This is great.
Awesome. What's up, Mike?
Hey Mike, how's it going? Heck yeah, man, that was an awesome podcast last night. Yeah, man, he's gonna go places.
Yeah.
That's good. At least, you know, somebody's going somewhere. That's awesome. $583. See, this is only one of the 4 hooked up because I only have one transistor that works. I got this other one that works, but they're not the same, so you can't run them on the same parallel circuit without one of them being burnt out. Not being able to like handle it. Alright, so I'm going to show you guys my gyroscope. I'm going to turn it on here. I got it hooked up to this amplifier, DC amplifier kind of thing, transformer. And we got some awesome arcing and stuff going on. This is 87 volts. I think that's sweet. I think reducing the number of magnets and the number of coils really helps. Heck yeah, we just hit another gear. What's going on?
Wow.
Hell yeah. Alright. And I can turn this thing up, but you know, it's gonna blow the reed switch eventually. Keep turning it up. But yeah, man, that's sweet. Now, if somebody could tell me what's going on with this FG thing over here, why both of these motors won't run at the same time. Because, you know, this right here, when I plug this onto the collector of this motor, which I'm not going to do when it's running at 63.3 volts. That probably would be all right, but I'm not going to do it. Now this, if I hook it up now, it'll be without all the safety stuff. And I mean safety for the transistor. I don't mean safety for me.
Hey, Sebastian, thanks for dropping in. Thanks for the subscribe.
Thank you. Alright, I think I'm going to take this core out. Because it's an anomaly in the system. It's really strong compared to all the other cores. Bam! So I got a hacksaw coming. I'm going to make this, you know, fit into the freaking coil. And then have another one to use in a different coil. That's going to be awesome. Alright. So, oh wait a minute. Do we want to put the light on for sure. You know, I'm going to start fresh because I don't think I have enough space.
Okay.
to put all the stuff on and I have them not connected, not touching each other. Collector, gotta move it up. That's good enough, I guess. Emitter, it's good. And we'll get the light. Yeah, I was shocked. I went to go buy a transistor and they're all gone. Just temporarily out of stock. I'm like, well, if they're coming from certain places, they're probably going to be out of stock for a while. So I opted and stayed in the same venue, but I switched brands. So, and there was this one that I liked. It was $35 for 5, and but it was like a computer generated image of a transistor, and I was like, I'm gonna pass on that. All right. So lights up. And now we'll put the shots in. Right. Now, bam. All right. Now, let's see if that works. Let's see if it's going to even work like that. I might have to switch the shot ski. Oh, nope. Something's not right. I'm willing to bet that might be it. Let's see. So we'll flip it around and see. Good. You can always tell because it'll start jerking the motor around before you start it. If you got it hooked up right or not. So you don't want to jerk it. That's what you don't want. And this is with a resistor of 470. So that, I believe that's what's causing our lack of speed. It might be actually, let's see. We can get some momentum in there. Alright, so we're going to try and hook this motor up again. And then we'll see if we're taking the resistor out, because it's at 63 volts. I mean, there's obviously a functioning transistor. Resistor's getting in the way. That's my hypothesis.
Okay.
There's too much resistance. it's not going to do both. I've already done this like 3 or 4 different ways. As soon as I hook up that motor to this one stops. And I don't know why. It's probably the transistor that I have it hooked up to. That one's moving pretty good.
Yeah.
And it's only hooked up through the continuation of the SG circuit from the collector. So it's like, it's the same energy that's coming in from the power supply almost directly. But that's cool. I think that's good.
Yeah.
I don't mind that this one isn't moving right now. It's not bugging me that much. But if anybody's got an idea as to why that is happening, maybe we could fix this. $36 volts. Let me get a tachometer reading on this one. 729 at 30 volts. Oh wow. Okay, that's way too high. This is an N. This is a different transistor, and it's probably pretty hot right now. All right, so I got the perfect solution for this. If I want to run both pulse motors. And it's not a perfect solution because the transistors still require different voltages. So one's going to be running good and the other one's not. And then when you try and make them run the same, one of them's just going to burn out. Alright. Let's see what we got. We'll do like the max for this one. 24. See, I got the trigger hooked up on this one, so it's boom, they're good to go. And I didn't even do that yet. That's pretty cool if it's working. So what I did is I shifted the power input from SG on this one to main power input from the power supply. Running exactly the same. Goodness gracious, there it is. Actually running a little slower. But we are running at 23 volts instead of 30 plus. What's going on with this one, man? Oh yeah, this one needs it to be at 63 volts for it to run really well.
That's right.
It's a transistor. It's like it's a high voltage transistor. It needs the voltage to function well. So that's running about 200 RPMs. 701. This one's increasing a little bit at a time here. 703.1. $159, 154, 147. Got an idea? Naked. We'll try it naked. Since we can't hook it together, we're going to try it naked. See, now it's working with the squeak. So I don't know, man. The SG setup, or the setup that I was explained how to set up. It was just simply, put a Shasky across base and emitter. I had to figure out exactly, what to do with that. I switched it around a couple times, and when it works, it works. If it doesn't, it doesn't. You know what I mean? You know which way is right. That's basically what I'm saying. And then the light, the neon light, and then the extension of the power through the collector. It's like an extension cord. It's awesome. But it's somehow, for some reason, it's not working. It's not producing. It's not doing what it should. So, you know what? When something doesn't do what it's supposed to do, you take it apart and start over again. Pulse motor mayhem, here we go. Oh yeah. We got 3 of them going right now. To hook up the little sync motor over here, and you have 4 going. I never thought it would work so well. It's working so good. Yeah, Peter Hall Effect 2.0 gave me the idea of putting the bell on the top. It's awesome. think the only thing that really damages my switches is me being clumsy with clips and accidentally connecting two things that shouldn't be connected at the wrong time, and just because this is functioning like really good, and it's only 4 that are active. 1, 2, 3, 4. It was just how I had it hooked up that was the problem. There's not 8 coils on this pulse motor right now. We're running this pulse motor, and I was going to run a parallel circuit of 4. That's why there's 8, but I don't have another transistor that'll run at the same rate. It's really important that these 2 transistors be the same when I put them on here. Because one will burn out the other one. It's happened twice. I don't need it to happen a 3rd time for it to be scientific. You know what I mean? Man, I'm happy with what's going on right now. Everything's moving. I'm thinking maybe if I keep it at an honest level here, like 30 volts, but no, it won't work. Because I tried it, we did it earlier today, bro. And did you see it almost doubled in speed? Like it was going fast, and then it was going really fast. And then the 36 blew out, just gave way. It was really hot too. It was extraordinarily hot, but it wasn't from lack of switching that it was hot. It was just being used, switching from being used. It was hot from being used beyond its capacity. The temperature was hot. Yeah, I don't know. Me personally, I always felt one coil was boring. Even if it went 8,000 RPMs, man, it's just boring. To me, anyway. I don't know. Just me. I like wrapping wires. I like doing stuff. I don't just like, it's done. Now let's go live life. Screw that. I'll tell you what, man. If one of these 2 switches blows out tonight, I will make 2 1-coil motors. I might even do it anyway. With a coil like the size of that 3-pound spool over there. I mean, from what I gather from copper wire is that it doesn't matter like what kind of wire you put between something, it's going to add either resistance, so it's going to reduce the strain. From what I have gathered so far, you know, having more copper in your circuit will reduce strain by increasing resistance, ohms. Mainly that, and I'll put a coil in there just to increase resistance. offset, not even part of the motor. I don't know.
Mike says you're right. Yeah. You just amp draw like that.
It's not only what's coming out of the power supply, but what ends up on the other side of the coil.
But with more turns on the coil, you step up the voltage like a transformer does. HV, high voltage spike. Okay.
Right, all these are 600 or less turns. I mean, we could do an ohms test for the entire circuit real quick.
Hey Bob, welcome to the channel. We are doing some pulse motor experiments this evening.
I mean, it's pretty much a balance, you know? Oh man. And then one of these days, it's just gonna open up. And it's gonna be going like 4,000 RPMs. I'm gonna be like, dude, I think I broke it. I'm not hoping for that really, but that would be cool. Yes, kind of. Yeah, there's not much of a clear end here in this coil. And I don't even know where I got this coil from. I found it in the bottom of a box. It's 26 gauge. It's pretty fat. And I'm like, how many turns in there? There's got to be over. This one's got to have over 1,000 in it, for sure. But all these big ones, 666 all the way around. Alright, so the ohms test is for this coil, this coil, this coil, and this coil. All the cardinal directions there.
What's up, Noah? Appreciate that.
So total ohms is probably going to be about 50. The magnets are still kind of shaking a little bit. Yeah, 49, 50. It settles right around there. But since this is maglev, I doubt it's going to stop jerking anytime soon. Back and forth. But I'd say it's right in between 50 and 55 average. So there's like no resistance in this one. And I did that kind of on purpose.
Oops, trying to zoom out. There we go.
So you're telling me that as each one of these coils collapses, each one of them sends a spike? Is that what you're saying, Mike? And that's what's damaging my transistors? You're still hanging?
But then Noah asked if you were able to check out the design yet.
Yeah, man, I incorporated your design into this gyroscope over here.
Have you seen this yet, Noah? We'll break it down.
Yeah, let me, dang. There.
Yeah, for the battery.
Alright. So this is the rotor with the coils in the middle. And there are 3 magnets here on this hood. And they're really powerful magnets, so they're guaranteed to hit your switch. You want to see it work? Have you seen it? Yeah, man. That was pretty cool. It inspired this. Peter Hall effect definitely inspired the top part. He said put a bell on it. I'm like, yeah, that sounds like it would work. And then, yeah, the rotor there with the coils in the middle and the magnets on the outside.
Yeah.
Yeah, I used. I'm gonna be honest, you're not the only one to mention that, but definitely you got me refocused on it.
Nice work, guys.
Beautiful.
Not yet. Haven't seen Peter yet.
Yeah, it's been a while.
And some nice arcing. Let me zoom in on the arc. Yeah, that's a nice one.
So that's about 89 volts in, 87, 89.
No, I haven't tried putting my hand in the arc. That's awesome.
Yeah, you could use a cap too, right? To get that arcing to stop, you could use a capacitor too, correct? And I mean, the original SG circuit was built on capacitors, right? But capacitors scare me, so I might go with a battery for sure. I might break down and just get a lead acid battery, 2 of them, and that's it. That's all I'm gonna do. But yeah, I guess my doors will open then. Is it a cure-all? I mean, I don't think so. I think there's 2 issues here. One is the way I've wound these coils. And let me explain. Most everybody winds their coils when they wind it. They go from left to right, and that's a layer. And then they go from right to left, and that's another layer. Okay? The way I do it is you go from left to right, and then you take 2 turns, just 2 winds, to go back to this side, and then you do another layer. So all the layers are congruent. I'm thinking what it's doing is it's creating a much different effect than, say, wrapping the coil the other way. That's one thing. And there is a place for that. And I think it's awesome, and when it's on, it's on. But it's never been over 1,500 RPMs. And I believe it's because the potential of the coils are limited. I subconsciously limited them. One factor was the amount, the cost in making a coil. Subconsciously in my mind, I'm like, I'm gonna have as much fun as I can making coils, not just using them, but making them. So that means I'd have to make a bunch of them. So in order to do that, you got to make them a little smaller. You gotta make them a little bit more personalized. Um, but you know, I'm willing to dump it all into one time, and like make one of those really nice size coils. I mean, if you're doing a 20 gauge coil, 350 ohms of 20 gauge is like thousands of feet. It's a lot of feet of 20 gauge to get 350 ohms, man. That's a lot of freaking wire.
Yeah.
No joke, man. That thing will end up weighing like 5.5 pounds.
Awesome.
Maybe. Maybe 6 pounds.
Mm-hmm.
You know?
It's a little baby.
It's a little baby. About the size of a baby's head. Like, just like that.
He's saying go 32 gauge.
32 gauge? Oh yeah, man, you get a little tiny coil then.
Yeah, a little 8 pounder.
Yeah, that was my first recommendation for a motor. To go 9 magnets and make all your coils 32 gauge. He didn't have a specification on how many coils or where to put them. He just said 9 magnets, 32 gauge. Go for it.
Yeah. All right, no, we'll see you in a minute.
All right, now. I don't know about you guys, but I like my little 4-banger over there. The Celtic Cross. That's a nifty little machine right there. So I want to build another gyroscope, but I want to use a transistor in my next gyroscope. And I really want it to be balanced. You know, I don't have any tools to do this stuff. Like, I eyeball all of it. And it shows, honestly, in the end product. And I do everything that I can. I wish there was just a button that would say align, and you know, it would align on right on the line. And it's, I guess there are programs that do that, not the one that I'm using.
Hey Brian, what's up? Welcome in. Good to see you. He says, what about using a high voltage diode to send the spikes back to the ground between each coil? Mike says that would be throwing it out. Oh man!
Talk about.
Where was your mind?
That was a
going?
great idea, but I mean that is being wasteful. In offhand manner of speaking, I don't have a battery right now, but yeah, I don't know. I mean, right now, absolutely, like right now, that might actually be a good idea.
For the performance of the motors?
I think both. Yeah, the performance of the motors and the arcing in the gyroscope. You know, if it's supposed to be going faster, I don't know what's wrong. I honestly don't know what's wrong. And hooking all that stuff up to the transistor does not make it go faster.
It's definitely singing.
Yeah. There's got, I mean, .32 gauge. 32 gauge coils instead of these thick wires. Use 32. That's what I like. I like 32. I love 32.
And then he said also a chemical battery instead of. Did you say an HLC or an HCl lead acid? I can't remember.
I know what I need.
Okay.
I do. I know what I need. I kind of put my foot down about getting all that stuff in here.
Got it.
And then I learned about the transistors, and they're made out of virtually the same stuff. So, I mean, whatever.
Oh yeah, HCl is
Bring it
hydrochloric
on.
acid. That's what's in our stummies, in our tummies.
Yeah, let's just not do that again, okay?
What now?
Say what now?
What are you saying?
I said, please, let's not do that again, okay?
Do what? Do what?
No, it's all right.
Yeah, I'm a little in lurch.
It's okay, man. Just I can't really explain it because it's like,
All right, I hope I don't do it again now.
all right, me too. If you do it again, I'll mention it as you're doing it. Okay?
Alrighty then.
All right. Oh man, yeah. All right. So I've got transistors on the way. Should I order a lead acid battery? Or two? I know lithium ions don't work. Do I have any other alternatives to lead acid battery? It feels like I'm going back to the Stone Age.
Dry cell battery.
What's a dry cell battery?
No acid.
No acid?
Mhm.
Oh yeah. But is that comparable? I know lead acid's the best to work with this stuff, and that's basically just because of the time it was all invented and created. It's all created at the same time. It's all made out of the same stuff, and it all like communicates with each other very well. So a dry cell battery doesn't work with this stuff like just as good as a lead acid, or maybe not as good but comparably. That is a really, really good question. And if anybody has the answer, I'm all ears.
He's been saying a bunch of stuff. I'm not going to read it out loud.
What's up, Ghetto Mining?
What up, ghetto?
Thanks, Mike. Yeah, I think I'm gonna just get try and use the battery. Okay. Yeah. Yeah, I got a few lithium ion or like nickel batteries. They're 12-volt battery packs, 2,000 amp hours.
Ghetto asked, can I throw you an image to see if it makes sense? The one I was talking about the other day.
Yeah. Yeah, heck yeah. Visuals are awesome. See, now I think there's an interaction happening here between this coil and this coil. Are you looking at that? Alright, are we gonna have to call it? Are you good? Alright. Hold on. I don't know, man. I'm getting like wicked clown vibes. Yeah, that's not what I thought you meant by a picture. Is there like a visual? I mean, I think Mike has a pretty good visual. And what? Or is this the legend? Did you just throw me the legend right now? Yeah. All right. So, are you
I mean, you're gonna do that again?
gonna put your hands down your pants for 5 minutes at a time again? That's what I was talking about. So no, I'm not gonna do that again. Right? Cool.
All right, man. I got about 20 minutes.
No, that's all right. I'm good. So, yeah, I don't know. There's probably a lot more I can learn tonight.
Why don't you try taking the phone and talking to the people?
Okay. You can
I can go chill and relax. So,
somewhere. Like, all right, cool. Sorry. Yeah, man. So like, when you're collecting a negative spike with a diode, does it have to be pointed in the direction that the negative spike you want it to go, or does it have to be reversed? Like this gyroscope over here, does it have to like, does the cathode have to point in the opposite direction, or just in the direction you want the electricity to go? Oh, nice. So it's actually like a full wave. That's cool. Okay. The anode points to the positive terminal. All right, I mean, this is really good information. I hope everybody who's here is paying attention. Um, If they don't already know, that's cool. If you know, no, I'm probably gonna have to milk your brain again. After I get the battery, of course. Mm. Yeah, the stripe side is the side that I want the electricity to flow in. Right, and it stops the electricity from flowing backwards, or what you have now made backwards by placing the diode in the circuit to begin with. Because until you do that, it's pretty much AC once it passes the first coil, right? Yeah, that's what I was asking you if I needed to point, because I'm always about forward. That's how I see things. I see things as the electricity is moving forward because the stripe is facing forward, and the electricity can't come backwards because the stripe is facing forward. No, I get that. I get that, but you're not getting that spike without a diode, right? Or is it? No, it's from the collapse of the coil, what you're talking about right now, right? Right, okay. So it forces a wave out, right? Just a whole wave, positive and negative. Uh, right, exactly. The diode gives the electricity direction, and it cuts the wave in half, though, right? Got you, Mike. Got you, Mike. Haha. Half bridge. Okay, right on. Oh, this is so cool. I finally got my maglevs like functioning again. I was riding on the bottom of the table and now, or I was just riding on the table and now I got it uplifted a little bit. And I got these rings and they're nice. They fit right around the rotor. So, yeah, even if I knew how to make that stuff, I wouldn't know where to put it. And then people keep on suggesting that I make a three-phase motor. I have no idea how to do that. I could learn though, but I mean, I got to talk to somebody who wants to teach me how to make a three-phase motor. Okay. Yeah, you got some pretty good stuff there, man. That's good. Oh man, I would put more effort into searching, but I'm not there yet. You know, I mean, I've been using the AI a little bit, but I don't know how to talk to a freaking computer. And besides, everything I've asked it for so far has been incorrect. Most of them have been pinouts for obscure transistors, but you know, still wrong. Should just say I don't know, you know. So do you see how this one would be so much better if I had another transistor? I've already seen it, and I guarantee you it would have been so much faster. Like, so much faster. All right, Mike. Uh, Yo, man. How do you check the battery life? Oh, is it up there? No. Oh, sweet. We got 29%. Now, I was running these little Bedini coils, 26 gauge and a 30 gauge trigger strand. They get really, really hot moving these motors. They are wired in series. They're wired in two series. So you got cardinal, um, I believe it's 90 degrees, and then you got northeast, you know, northeast, southwest, northwest, southeast, other way around. And they're hooked in series for each individual circuit. So I don't know. It's like and then there's just four magnets on here. So yeah, about the 369 are like the six magnets with the nine coils at with three 120s. Thank you, homie. Heck yeah. Thank you, Chris. Awesome. Christopher Hatton. Thank you. Yeah, so I've been doing this now for 2.5 years or so. Just I started off differently than I am right now. It was a lot slower, cleaner, different. Um, I don't know whether I've come, up are down. I know that I'm moving forward, but I don't. When I look at my old videos, I'm like, man, that was a lot cleaner and things were different. But yeah, we're moving forward, and in order to get from there to here, um, created a lot of videos of me doing experiments. A lot of videos of me trying new stuff. A lot of videos to get comments to get to where I'm at now. So and where I'm at now, I'm fully monetized. I got a membership. You know, if you want, you get you get a free 3D print every time you renew your master's membership. So, this is the printer that I have. So you get about 8 by 8 by 8 print. Those are like the dimensions. We got a Discord. We like to talk about stuff. But we also like to talk about not all that's been done, really. We like to talk about that. We like to talk about everything, really. Um, but you got to understand that you don't need to believe in free energy to do this stuff. That is not a requirement. Um, as soon as you understand what's really happening, you realize that it's not free. Free is the wrong word. I believe that Ben the other night said free energy is definitely rubbing people the wrong way. Because, just imagine for a second if you could get the physicist and the physics teacher to hop on board with this. That would be a heightened understanding of what's really going on. That wouldn't be me, someone trying to sell somebody something. This would be this would be a learning experience. And honestly, I do not see in the future us running our homes with one of these. I don't see that happening. I see that as being not a thing. Maybe some other type of renewable energy or something like that. Batteries, like batteries and solar combined. There you go, man. And yeah, I mean, I've heard, various, data, just lots of data. I've heard 700 volts. I've heard 800 volts. Me, myself, I've done about 643 volts on one of these pulse motors. It's not going to run your house. And that's okay. That's all right, man. This is all still really fun, really cool. And just to let you know, like it stopped. Whatever it was, it stopped. Stop moving. What do we tell everybody? I don't know, man. It stopped moving. Just tell them it stopped moving. There's so much stuff I want to do. I mean, just because this aluminum disc is on the table right here, I want to hook that up on something and maybe run this motor and get that thing spinning. But nah, I'm good. All right, we're gonna wrap it up in a little bit anyway. Thank you. Yeah, Mike, that's my point. Thank you for agreeing with me in uncertain terms. Yeah, man, a superconducting coil. How much money are we talking about to build one of those things, and how precise do they have to be? You know, just looking at that right there is like, it may never ever happen. And I mean, honestly, amplification is cool. It's not free energy though. Amplification is definitely a thing, man. I know when you put, and you don't convert, it's not a transformer because you're not converting current into voltage, and the current remains constant and the voltage goes up.
He said maybe it'll be worth it for Elon, but not anybody else right now.
No, I'm telling you, if that was real, things would be changing all around you. Even if only one person had one. Even if it was only one coil, it would affect the entire universe around it. Everything would change. And it's not like it would disappear or blow up or dissipate or any of that crap. It would just change. You know, it would be different after that happens. So if that happens, you will know it. Regardless if anybody tells you, you'll know. You feel something different. And I do. I think something like that has happened recently. Not like back in the 50s, but or even the 1800s, but like recently this has happened. And it's still not free. If you have to ignite it in any kind of way whatsoever, like even if you have to blow on it, it's not free. It's not about how much money it costs. It's amplification, it's exponential energy, which means you start off with maybe just a spark and it just never stops coming. But that's not free. That spark costs something. Even if it's minuscule. That's why we come to the point where free energy is the term that's rubbing people the wrong way.
Totally.
And I totally am on board with this stuff, but you gotta come up with a term that's all inclusive and encompassing and free. I don't know, man. I don't know what it is about me, but it's like sandpaper on my butt cheeks, man. It's like. And then it's like, if there's such thing as free energy, then I can complain for the rest of my life and people will love me for it. That's free energy. That'll never happen. You know what I mean? People are not going to love me for how much I complain. And unfortunately, I complain a lot right now. I mean, I screwed up, and a while back, and I'm having trouble like piecing it all together. But I'll get there. I'll get it together, and yeah. I don't believe in wearing masks for any kind of festivities. I don't believe in wearing emperor's clothing either. I will walk in there nude, knowing that I'm nude. Not thinking that I'm wearing clothes that are really cool. You know, I kind of just, and I don't, have a plan really. I mean, it kind of sounds like I'm developing one right now, but I just know that my next coil is going to have dimensions, it's going to have ohms, it's going to have stuff that is not just me picking a number that I like. And that's pretty much it. You know, we got the 666, we've got another 666 over here, we got 911, we got 1111, we've got a lot of that kind of stuff going on here. I mean, this one's got 22,000 turns, but I did it on an analog. So you can see how it's nice and fat in the middle. It's not, it's a really crappy coil, actually. I mean, that one generates 78 volts, and then this one, they both have cores, and this one can generate up to almost 250. It's wrapped a lot tighter. It's wrapped in attractive phase, so this it goes boom, and then back real fast, and boom, back real fast. Boom. And I believe when you do that, the north and south sides of the coil are really well defined. I wrap all my coils counterclockwise. Boing. And as long as I make that first layer like pristine, whatever happens after that is okay with me. Because I'm not taping every layer. I'm not going to do that. That's not going to happen. But I honestly, I try to do the same amount of turns per layer, and that's how I maintain uniformity, by trying to do the same amount of turns per layer. Sometimes it works, sometimes it doesn't. So, I mean, with that being said, I'm wondering what would happen if I, wrap the coils in repulsion phase, or what is that? It attraction repulsion? Yeah. So, and that would be front to back, left to right, and then right to left. And I think that might be what I want to do. To have the... I don't know if I need that though. I don't know. Because all the wires end up being on the same side, so one face is always going to be facing wherever it is going, so maybe having all that north on one side is a good thing. Like extra good. I don't know. Yeah, Mike, I'll check your channel. My scrutiny, I'll be scrutinizing and finding what I need on your channel. Yeah, I made one of those rodent coils. I think it was a 32 or 36 star, and the one where you just move over 2 and then down, and 2 and down. It's really neat. I didn't make it very big, but I got it in my storage unit. Maybe my next coil will be a rodent coil. Who knows? I'd have to get a former that makes sense to me. When I was in a podcast, I heard something about a lesson in how to build a rodent coil. But did I hear that right, Mike? Nice, Mike. I've spent about 4. No, I'm talking about benefactor. He's making a. He had a lesson to make a rolling coil, and he was. I hope people show up, is what he said. Yeah, Ben. Yeah, Ben. Yeah, I gotta say that last one last night, man, that was a lot more satisfying than the first one I saw. Awesome, man. He's gonna, like I said, man, he's going somewhere. That's gonna be awesome. I didn't know he lived in my area. But he kind of looks familiar. Honestly, he does. It's like I've seen him before on the street somewhere. I already know he's gonna be a superstar. Because you're right, man. He's got that attitude for success. I have an attitude that is bipolar as hell. Yeah, I'm up and down all the time, man. And if I see something that I don't like, man, you'll know it instantaneously if I'm being filmed, because my eyes will be like
The beady eyes.
Rasputin,
Mm-hmm.
straight up. Now, I want to get into the signal generator stuff. I really want to do that. And it's working with the ball, the magnet ball right below you.
There it is.
Yeah, the magnet ball works really good at 7. And if you can get it spinning and then manage to crank it up a little bit, I got it up to 38 hertz with it continuously spinning. From 7 to 38, I just upped it 1 hertz at a time. Now, I know that there's like some, well, I don't know about all that stuff, but I know that one of these coils is spinning really good. One of these coils, 20 gauge, 666 turns, is spinning really good. See, now this is what I think the Litz wire is good for, is making the Rodin coils. Because I believe that the higher the frequency in the Rodin coil, the better off it will be. So if I make a Rodin coil that's going to be 3D, I'm making it out of Litz wire, 38 gauge in a 5 bundle, 3 bundle, 20 wraps. So it'd be like 3, 20, 38, something like that. It'd be like a 20 gauge wire in the end, or 16 gauge thickness when you add it all together. I mean, that sounds like the right way to go for that, because it's going to increase about 100 kilohertz is what they recommend this wire be used. 100K. But the only problem with that stuff is that it's freaking expensive. Especially if you get enough to build a decent Rodin coil. Boing! It's like $2,500. But seriously, if I'm gonna build a rotor coil, that's how I'm gonna do it.
Okay.
I'm not gonna make my own. I don't have a backyard to do that. I don't have. Literally, I've got 20 feet that I can make that with, and I'm not even gonna try.
Or a minute. 2 minutes.
2 minute warning. All right. Well, I'm gonna keep plugging away at this, and you know, I'm gonna be the voice that says you don't really have to believe in stuff to know what's behind it and how it works. You don't. It's not a religious thing, man. It's it's very very scientific, and there isn't an understanding and an answer, even if it eludes you at the time and you're awestruck about what you see. There's always a magician behind this. And I mean, God is a good magician. I just said we weren't going to go religion, but I mean, seriously. And all I mean by that is you saw something and you don't know how to explain it. You saw somebody do something and you don't know how to explain it. And then you learn. See, Mike is a great example of what I'm trying to convey. That the learning process starts with that awestruck child and begins to Mike, I believe you said you've been doing this for about 25 years, right? All right, well, I'm going to check your site out, but we got to go. Talk to you guys later. I really appreciate you. Have a good night. Please subscribe, join, check out my Patreon. Bye now.